Hello students, welcome to our first online session for the lab of the course Computer Organization with the course code EEE343. I am Ali Roman and this session is specifically designed for the students of BEE7A. So in this session basically we will be having introduction to the labs and we will be having introduction to the software that one of the software that we will be using in the lab for implementing our designs and describing our designs by using Verilog HDL. So let us first see the contents which we will be covering in today's session. So in today's session we will be having the basic information about the software, the interface of the software, and how you're gonna get access to the software, how you're gonna download the software from Mentor Graphics website, and we will be having a short demonstration in order to show the concepts and implementation methodologies which we will be using in order to describe our design using Verilog HDL in Model Sim Student Edition. As far as the basic introduction to the Verilog HDL is concerned, we can use any book that is used for the description of the designs in Verilog HDL. We can also use chapter number 3 that basically covers the basic designs and basic implementations in Verilog HDL of the digital modules. So we can use digital design with introduction to Verilog HDL by Maurice Mono for explanation of the concept and to get familiar with the syntax of the said platform. So student, to start with, how we're going to download the software, basically we have to get access to the Mentor Graphics website. So what you have to do is you have to download the Model Sim PE 10.4 Student Edition, that is free edition, and that edition has a dedicated license file for each download for each student for specific hardware setup. So what you have to do is you have to access this website and you have to fill a form in order to download setup. So let us see the website which we will be discussing. So this is the website. Well, this is the website and you will fill a form like this. Basically you have to provide the basic information regarding your name, your email, your phone, the company or the institute for which you are using the software, your job. Basically you are a student, you have to select a student here and your address here. You can use your institute address here and specify a country region, and you have to submit that. Afterwards your download starts and it's around about 300 MB software. First of all you have to download the software, then you have to put a request for the license on a mail, and within 24 hours the license file with extension .dat is sent to you on your provided email address. And what you have to do is you have to copy that license file into your installation directory in order to properly make the configuration of the software. So what you have to do is the first step is you have to download the setup and you have to run and install the setup. After successful installation, you are required to put a request for the license by filling a license request form. And the software will automatically take you on the link for the license request form. So you have to fill that, and once you have filled the form, the license file, basically that is license.dat, will be sent to you on your provided email address. So what you have to do is you to download that file, copy that file into your installation folder, and for detailed instruction you can visit this website that has been mentioned here. This is the website. So let us start the demonstration of the set software, and let us see the website from which you have to download the software first of all. So basically this is the website. Basically this is the website, the link which is provided to you in our previous discussion. So what you have to do is you have to click on download student edition. And you have to fill this form basically, and you have to submit this form. Afterwards your download started, and what you have to do next is you have to install the software after the completion of the download process and put a request for the license file. One thing you have to make sure that the downloaded file and the downloaded setup is for the particular hardware for which you have initiated the process, and if you copied that setup or the license file on some another system, it will not work. So each student has to download its own copy of the setup and put a request for the license file. So let us start with the software. Basically this is the software, that is Model Sim PE Student Edition 10.4a, that is basically used to describe our design by using Verilog HDL. As far as the Verilog HDL is concerned, it is a language, it is a platform to describe the hardware. HDL stands for the hardware descriptive language. And if you are familiar with C, its syntax basically resembles with C. So what we have to do is we have to describe our modules in order to describe our design. In the same way we are describing our classes in C++. So the modules basically represents our hardware component or the system or the digital system, and for which we have to describe our design. So this is the primary setup interface. If you can see that these are the setup libraries here, and the next window is that sub window is that is the transcript window. All the processing, all the warnings, all the compilation information you can see, you can observe in the transcript window. And this is the command window also. If you want to execute or process some dedicated setup or dedicated command or dedicated module you want to call, just like you want to run some particular hardware, we can also use this. So the first step is we have to create a project here for our design, for any digital design which we want to describe. So we will access this file menu. We will click at new, and we will select from the menu that is project. So the first step is we have to define a project. We have to describe our project for that design. For example, the project name is CO Lab 1. Then what you have to do is you have to specify the project location. So try to make sure that you will implement the project in well-defined path, in well-defined folder. For example, in C drive, I am making a new folder. That name is CO Lab 1, for example, and I am selecting that folder and pressing OK. Now if you observe the path here, it's C colon slash colab 1. The default library name is work. Basically, this is the folder, this is the library in which all your compilation is done. And we are copying the settings from this specified path. So we are not changing the settings. And we have to press OK. Now the next step is to add some files in our project that are basically the Verilog file or the VHDL file or some other platform files. Basically, we are using Verilog HDL as our implementation platform to describe our design. So this is the first time. So we have to do is we have to create new file. We have to give a file name. For example, AND gate. Basically, we are implementing a file to implement or to describe a basic AND gate in Verilog HDL. So what we have to do is we have to select the type of the file as Verilog and we have to press OK. So this would be our design file with the name andgate.v, and we have to add another file that basically contains the test bench or the test driver circuit that is used to simulate our design basically. So you can imagine the setup which you have used in your DLD lab. What you are doing is that in practice basically you are implementing your design on a breadboard, you are making your connections, you are giving the inputs and observing the outputs. So assume that you have made this AND gate IC. Now you have to use that and you have to create a test environment or a simulation environment in which you can give inputs and observe the outputs in order to verify the functionality of your design. So we have to create a test driver circuit or the test driver or the test bench that basically used to simulate our design in order to verify its functional simulations or functionality. So let's name it as TB, that's for the test bench, underscore AND gate. We have to select the file tab as Verilog also and press OK. Now in our design, in our project, that is basically stored in this folder C colon slash colab1, and the name of the project is also colab1, consists of two files. The one file is your design file that is named as andgate.v, and the second file is your test bench file that is used to test the functionality of your design, and it's named as tb underscore andgate.v. Now let us see the basic syntax in order to design or any digital module or component using Verilog HDL. So we have to select that file, open that file in any text editor of your choice. So ModelSim do have a default text editor. Now you can see that that editor is open here with C colon slash. This is the file we want to edit. So we start our design description with the keyword module. One thing which you have to make sure that it is a case sensitive platform and all your keywords are basically in smaller case. You have to think about that and you have to be careful about that. So first of all, we have started with the keyword module. The module name, it's AND gate, and then we have to specify the ports or the pins of that module which are used to communicate with that design. So let us name as A, B, Y, place a semicolon at the end, and we end our module with the keyword end module. Now the next thing is we have to specify, we have to tell our design that these are the ports, these are the pins that are used to communicate with our design. What are the pins that are used for the input and what are the pins that are used for the output. So we have to specify the type of those pins. So we will use the keyword input in order to specify the inputs. For example, A and B are the inputs and are the scalar quantities. So input A comma B and semicolon, and we have to specify the output, that is Y. We can describe our design, any digital design, in different modeling techniques using Verilog HDL. So either we can use the gate level description of our design, in which we have to use some built-in gate primitives in order to describe our digital design. For that purpose, you should have a logic diagram in order to implement that design. Then we have the data flow, and the higher level, the top level, is basically the behavioral modeling, in which we have to specify the behavior, and that is a bit similar to C if we consider the syntax of the platform. So these are the three levels, common levels, that we can use in order to describe our design. So this example, basically this demonstration covers the gate level modeling here. We can also use a more detailed level, that is a switch level, hardware level, basically, in which we have to implement our design by using some built-in switches. For example, in order to implement our design in PMOS or NMOS, if we are using the CMOS implementation technology. So these are the built-in switches we have to use. So this design is basically for the circuit level implementation. So we will start with the gate level, and then we'll gradually increase our description level towards behavioral modeling. So since we are using gate level modeling, we are basically implementing an AND gate. So we will use AND primitive in order to describe our design. So we'll start with the keyword AND, its instance name. This is the first instance of the gate. For example, this is the first gate we have to implement, and with the name inst1 in order to identify our described component in our simulation diagrams. And then we will specify, first of all, the output of the design. This is the syntax which you have to remember. So first of all, you have to specify the output, then inputs, and the description is complete. We cannot specify this AND gate in this way, and instance 1, this instance name are basically the optional, so you can avoid that, but it is recommended to you properly give names to your instance. So I cannot use it as A comma Y comma B. This is not allowed. We can switch the placements of A and B, that is okay, but we cannot switch the placement of Y with respect to the input. So Y would be, the output would be the first that should be described, and then later on the inputs. The comments are given with double slash, so you can see that I have written this line. This is basically a comment, so we cannot use this. So let me write, we cannot use the syntax like, okay. So this was the comment. So this is our complete description for the AND gate. If our design contains some intermediate connections, so what we have to do is we have to define some wires here, as the same way we are using wires in order to connect one IC to another. For example, now we have a design, it's just for the example, we have our design with 3 inputs and 2 outputs, and for example we have a setup like this. We have a gate, the OR gate, for example, just for your example, or its instance name, the and its second instance with a unique name. So here this C basically represents our wire that basically connects our OR gate, this OR gate. Let me comment this also. This OR gate that has the inputs A and B with this AND gate that has the input A and the output of that OR gate. So the output of the OR gate is connected with the input of the AND gate. So we have to define a wire here. So how we're going to define a wire here? Let me skip this C. I think it's sufficient to explain the concept. So we'll define a wire here with the keyword wire, and the name of the wire is C. So if we have to define some intermediate connections that are basically used to connect one module or one design component with another design component, so we have to define wires here. So let's switch back to our main design. So let me comment this also, and this also, and this one. Let me skip this input, this one, and also the wire. So this is the description for our AND gate. We have to save this file, and the next thing is to see if there exists any syntax error. We have to compile our file. So what we can do is we can right click on a file, select the option compile here, and we can select any of the option here from the compile menu. This is the first way. The second way is we can use this compile menu with file edit view option, and we can compile all, we can compile the selected file, we can compile in particular order. So these are the set of options which we can use. So let us compile this file, select the option compile, compile selected, and here we get the message that compile of this particular file was successful. If any error exists in a particular file, for example, let me omit this semicolon, save the file, and see the status of the file is unknown again, is question mark, and let's compile this again. Now you can see that this particular description contains an error. How I'm going to identify the error? You have to click on this line, and here you can see that the description of the error is shown. For example, at this particular location near end module, we are getting syntax error. The system was expecting end module, expected end module, we have end module, and a semicolon or a comma here. So this is basically the description of the error. So uh, we can go on this at this particular location, and we can see that here with end module, near end module, we are missing a semicolon here, so we're placing a semicolon here and then saving the file again and then compiling it again, and see the compilation is successful. Now let us implement our driver circuit for the test bench, which is used to simulate our design. So we'll go to the file tb_andgate. So we'll start with the keyword module. The name of the module, that is basically, this is the name, and semicolon. Our test bench modules basically are the modules that do not have any port list. They don't have their own ports or the pins. Basically they will be using the design ports which is used to be simulated in that particular test environment. So you have to remember that the test drivers don't have their own ports. And then we end with the end module. Now what you can do is you have to specify what are the ports of the design which you want to simulate the design. So one thing which you can remember that you have to describe your design inputs as with the keyword reg, and the design outputs with the keyword wire. So our inputs can be simulated with our inputs are basically the registered inputs, and the outputs are basically represented with the keyword wire. What we can do is we can go to the design description, simply copying these two lines. If we are using the same naming convention here for the inputs and outputs, paste it here and simply replace this input keyword with reg and output keyword with wire. Now the next thing is that we have to instantiate our design. Basically the instantiation is a process of calling the design into the test environment or some other module. It's just like calling a function in C or C++. So we'll instantiate our design with a keyword or the design name that was basically AND gate. This is the name of the module. Its first instance, for example, the instance name and the port list. In the same way we have described our design, so A, B and Y, we have to follow the same order. Later on in our later session we can see that we can avoid by calling instance by name. We can also use instantiation by orders, in which we can place our port list in any order, but for the starters we are instantiating our design by names and the same representation basically. So that was Y, comma A, comma B, placing a semicolon. You can assume that at this stage you are implementing a circuit on some platform, for example breadboard, and you placed an AND gate IC on a breadboard. Now you have to connect those with the inputs in order to verify the design. In order, you have to provide A and B inputs and to see the output Y. So here now we're gonna provide the input instances. So we'll start with the keyword initial. We have to give our inputs in the initial block, that is basically to represent our inputs, and this block is executed once basically. So initial started with begin and end. Begin and end are basically similar to the brackets which you are using in C++. So we've got inputs, for example A equals 1 tick, B 0. Let me explain that. B equals 1 tick, B 0. So this is the syntax basically in order to specify any input. What does that represent basically? So basically it's input. Let me write it in a comment. Input name equals size of the input, that is been specified with this tick, size tick basically. Then it's regex. So I am giving the input in binary, that's why it's B, and the next thing is the value. So for the first input A, basically this is a single bit input, it's 1 tick, this is single bit, it's in binary, that's why it's B, and its value is 0. Similarly for the B. For the next inputs, for example, I am saying that when our simulation starts, A and B should be 0, 0, and after 100 time unit, hash 100, basically it's a software delay. So whatsoever our simulation time is, that after 100 time unit, our input should be changed as A should be 0, B should be 1. After another 100 time frame, this is 1 and this is 0. And after another time frame, 100 time frame, both are 1, 1. Now our simulation environment is set up for that particular design. We have to save our design, test driver, and compile our design, which we can see that the compilation is successful. The next thing is to simulate our design. So what we have to do is we have to go to the simulate menu here, and we'll start our simulation. So basically our compilation results in the work folder. So we have to select this work folder here, and you can see that we've got two instances here. The first is our main design, that is AND gate, and the second is the test bench basically. So we have to select our test bench instance, and we can set the resolution of the time as per your requirement. So I'm just running the simulation with the default resolution and press OK. Here we got an error in a design. Let's see what's the error. So let us re-verify our design files. To see any error here. And we can see the error here, that our design contains the order in which we specify our inputs first and the output. If you can observe that here, it's A, B and Y, but we are connecting here in such a way that we are connecting Y with A and B with Y here. So basically we have to use the same order here. So it's A, B and Y. Now the order is same here. For the correct mapping of our inputs and outputs, we have to save that file. We have to compile all the files, for example compile all, and then we have to simulate our design. Start simulation, select that particular file, that is this one, press OK. And here you can see that some sub windows are open. For example, the object window that contains all the objects that are appearing in our design A, B and Y, and their value is shown in hexadecimal. You can change that into binary as well. These are the instances. Basically, what are the instances which are in your design? For example, and instance 1 that was in our test bench, and if you click that, it has an instance 1 basically, that basically represents the instance in our main design file. Now what you have to do is basically you have to generate a timing diagram in order to verify the design. So what you have to do is you have to add these to the wave, all the instances to the wave, and you can see that now here A, B and Y are added to the waveform. Now the next thing is to generate the timing diagram. We have to run the simulation. If you can see this window here, this one with time frame 100 nanosecond each step, this is the run length, and we can use this run option in order to run our simulation, and you can see that a timing diagram is being represented here. Now how you're going to verify? Basically it was simply the AND gate, and if both the inputs are 1, basically the output should be 1 here. So if you bring the cursor here, A is 0, B is 0, the Y is also 0. Then A after 100 time frame, A is 0, B is 1, Y is still 0. Then A is 1, B is 0, Y is still 0, and when both are 1 1, Y is 1. So by timing diagram, we basically verified this, the functionality of our basic AND gate, which we have implemented by using Verilog HDL. So students, this was all for the today's lab session. I hope so you will be able to use the software and you will be able to describe the design in Verilog HTML. In this lab session, basically we will be implementing some basic modules or some basic digital designs using Verilog HTML, and our modeling technique would be gate level modeling, and we will be implementing that in our physical lab session, which is scheduled to be held next week. See you then, students. Best of luck.